fits the pattern of a squared minus b squared, where a is a binomial. If you can see that, then it makes it easier because it fits the factor pattern of a plus b times a minus b. And so what you could do if you recognize that form is you can say that this factors into a plus b times a minus b, where your a is y plus 6, your b is 11. Those are the bases that are being squared for each of those. And so it factors into the sum times the difference of those terms. Now, you can have parentheses around the y plus 6 if you want. You will need the parentheses if it falls at the end, like these two examples down below. But if that's the case, what you then do is just simplify each of these factors. So y plus 6 plus 11 gives you y plus 17. Y plus 6 minus 11 gives you y minus 5, and there is your factored form. Okay, what if we look down below? So below we have this pattern of 9 squared minus z plus 9 squared. So once again, it does fit that a squared minus b squared pattern, which would factor into the sum and difference of the bases being squared, which are 9 and z plus 9. If that's the case, because this one falls second, you definitely want parentheses. So if, again, you want to get in the habit of doing that every time, you're good. But it becomes the sum and difference. And you need the parentheses here because in this particular case, that negative is going to distribute. So you get 9 plus 9 is 18. So you have z plus 18. Your second term, here you have 9 minus z. And then minus 9, so 9 minus 9 is 0. So you have this set of factors. And you just want to write your monomial factors before your binomial factors. So negative z times the quantity z plus 18. And that gives you your factored form. Okay, I want you to try these two examples here on your own. See if you can come up with the correct solution for factoring each of those. Now, the alternative to this is something that, because we haven't talked about the reverse foiling stuff yet, the other option for this is you could apply the rules for binomial square, expand out your terms, combine any like terms, and then try to refactor that, which, again, will also work. But if you can put it directly into this form, it makes it easier. You're using smaller, easier to use numbers for your factoring these remaining problems. So the first, if you recognize that it fits your pattern, you have the a squared minus b squared. 100 is a perfect square, so is the binomial square. Okay, so this factors into the sum and difference of those bases. A is this binomial 5s minus 4. Again, you can put parentheses or you don't need them. If it's the first term, I'll just put them to be consistent. And then the second term, the base of the 100 is 10, so plus 10 minus 10. So it's the sum and difference of the terms is the factor form. And now we just combine our like terms here. So I have a 5s minus 4 plus 10 gives me plus 6. Here I have a 5s minus 4 minus 10 gives me minus 14. There's no common factors to remove from any of those terms or the binomials themselves. And so this would be my factored form. And again, make sure you remember to use the correct variable for these. Something like s is not kind of the norm. And then the very bottom, same idea here. You have 10 squared and a binomial square. So this is the difference of squares. So it's going to factor into the sum and difference of the terms. Base 10, base 2v plus 11. And it factors into the sum and difference of those. So if I distribute my terms through and combine, here I have 2v, 10 plus 11 is 21. And then here I distribute my negative, giving me 10 minus 2v minus 11. Okay, and so when I simplify what I have right here, this is negative 2v minus 1 is the factor when I simplify it. And I do want to write my factors in standard form, so the highest degree terms first. I also want any non-monomial factors to have positive leading coefficients. This one has a negative, so I'm going to take that negative out, put it in front. The 2v plus 21 stays exactly where it is, but I'm going to change the sign of each term in this because I removed that factor of negative. So this becomes a positive 2v and a positive 1. And so that would be our simplified form.